Video number 113, graphing rational functions not in lowest terms. What you may consider doing as for f of x here is we're going to factor the numerator and then cancel out the x plus 5s. We're simply left with x minus 5. So therefore we can say that f of x equals x minus 5, or in other words, y equals x minus 5. This is the answer to this problem. Now, if for whatever reason you didn't recognize that the numerator factored, you still could do the synthetic division and divide. You just have to make sure you put a 0 in for the middle term, and you will end up getting, excuse me, it should be 25, here you go, 0. So you'll still end up getting a 0 remainder, and hopefully you'll notice this is obviously x minus 5. So we're going to graph the line. So this is the line x minus 5. So obviously we would go down to a 5 here, up 1 over 1 all the way until we get to a 5 over here, and then this would be the line we're looking at. Now here's the deal though. You see, there is a problem in our domain. And the problem in our domain is this. F of negative 5 does not exist. So how do we indicate that? Well, here's 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5. This point here would not exist. So we would draw a line through there, but we would have an open circle. And my open circle is a little bit off, but you would have a hole in the graph. You'd have an open circle there, and this would be the correct graph for f of x. Okay, so this is the first example. We'll take a look at another one here, but basically what's going to happen is you're going to factor, you're going to cancel, and you're going to just graph what you have left over, but you have to remember that there's a hole in the graph at the number that has a problem in the denominator. It makes the denominator 0. That's why f of negative 5 does not exist. Even though f of negative 5 looks like it's negative 10, in fact, we would be down here at a height of negative 10. But that point does not exist because it doesn't exist in our domain. Alright, here's g of x. Same strategy. Factor the numerator, take out a negative 3. You're left with 5 minus x. Then 5 minus x and x minus 5 cancels out to becoming a negative 1 right there. So negative 3 times negative 1 is 3. So g of x simply equals 3, which is obviously a horizontal line up 3. So we're looking at this graph. I'm going to do it like this, okay? Because where's the problem at? The problem is this. G of 5 does not exist. So therefore, when we go over to a 5, 1, 2, 3, 4, 5, that is going to have a hole in the graph. It is a height of 3, yes. 1, 2, 3, okay. But because of the original, obviously there's no domain issue here in the final answer. But in the original g of x, there's an issue at 5. G of 5 does not exist. Even though someone might say it arguably equals 3, it does not equal 3. G of 5 definitely does not exist. Now, you may do limits. You may find the limit as g approaches 5 is 3, but it does not exist. G of 5 definitely does not exist. All right. Good luck, guys. Good times. Talk to you later.